we've been looking at graphs this whole topic, right? And so that's why I'm just going to quickly get back into our head the 3 different kinds of graphs that we've looked at in a very quick form, okay? But I'm going to do more than that. I'm going to tell you what these graphs, what they're really about. And then I'll tell you what the name of the process is, which is the heading, okay? So for each of these, I'm going to give you an analogy, right? A situation that will match up to what the picture is like, okay? So here's my first picture. My first picture is about donuts, okay? Donuts are simple, but if you go to basically, like, I think it's extortion, right? The schemes for prices of donuts are ridiculous, okay? There is a little bit of like, oh, if you buy this many donuts, it'll be a bit cheaper and so on. But essentially, it's like, yeah, they totally are. Absolute money-making exercise, I suppose that's the point, right? So if I buy 0 donuts, right, I'll call this my donut axis, okay? How much am I going to have to pay? What's the cost? So this is my cost axis, right? And the answer is if I buy no donuts, I'll pay nothing. The cost is 0. Okay. So if I buy donuts. So, okay, now, as I buy more donuts, just if they're like, say, $1 a piece, right? You're getting something like this. Okay, yeah, I know. Who am I kidding, right? If I got $1 donut, I'd buy the whole shop. Now, there you go. Basically, that's what's happening. More donuts, more cost, and this particular shape, as it goes up in a straight line, we call these. We call them linear. Very good. Straight lines. Okay. So there you go. There was our first variety. Donuts was the first analogy. The second analogy is area. So what if I were to give you a square, okay? So I don't have a square-shaped object here, so I'm just going to draw one. Okay. So if I have a square, and in a square, all you need to know for like its dimensions is you need one number. How long the side is, right? Like this. Because once you know that, how do you find out the area? If it was, say, that looks like maybe 5 centimeters from top to bottom.
5 times 5.
It'd be 5 times 5, you'd square it, wouldn't you? Okay. So if I have here, like how long is the side? So this is my side axis, right? And if I compare that to the area, okay, the area is going to be the side and squared, right? So area equals side squared, right? Now there's 2 axes, but we usually label them, on these kinds of things, we usually label them x and y, right? So this would be y equals x squared. And we know what this is. What shape's that going to give us? Parabola. A parabola. Very good. Okay, so we're going to have something like this. Now you'll notice I've only drawn this half, right? Because what would this side of the graph mean?
Negative.
It would mean, yeah, the side length is like minus 3 centimeters. It kind of doesn't make sense in this particular situation. Okay, so I'm just going to kind of put a dotted line over here because a parabola has 2 halves to it. But in this particular situation, as with this one,
well, what
doesn't necessarily make sense. Okay,
so
so
need to draw the other half.
Well, it depends on the situation, doesn't it?
But suppose if it's like that, do we need to draw it?
No, I'm just putting it there to show you.
Oh, but is it parabolas both sides?
Yeah, that's right. The shape keeps on going. But for our situation, which is area, our analogy, it doesn't have meaning over here. Okay? Okay, third analogy. I want you to think back to when Simon Pompidou came along and he gave us that performance down the MPC, right? And he talked about disease. He talked about infection. Okay? Now, I know infections and like epidemics and that kind of thing are complicated things, but very simply, the idea was that you start with one person who's sick, and then he makes his neighbor sick, right? So one sick person turns into 2 sick people, right? But then these 2 guys, they make another 2 sick people. So 2 turns into 4, right? And then 4 is going to turn into, every one of them is going to make another person sick, so that turns into 8, and so on, right? So this number keeps on doubling and doubling, right? So what would this look like? It's going to climb, and it's going to be, exponential, right? And we've seen before that this graph, it sort of goes down like that toward the axis, okay? So if we had, let's see, this I suppose would be time. As time progresses, how many sick people do you have? And that number is going to increase exponential until, of course, people start dying, so they can't infect people anymore. Okay. All right, so I gave you 3 analogies, right? donuts, area, and infection. I have a fourth analogy for you, but this time I'm going to do better than words, right? I'm going to get out, this is what I had to go and fetch, okay? Here's my fourth analogy, okay? Now, my fourth analogy is, well, actually I need to open this. So, would you please do the honors? Open it up for me, because it's sealed. I haven't opened it yet.
You never know.
I picked someone who was trustworthy. Did I make a mistake?
Yeah.
Okay, all right. Thank you very much. Okay. Now, what I'm going to do with this, right, is first I want us to know how many chocolates there are in here. Now, what do you guess?
24.
21.
I'm guessing it's going to be between 20 and maybe. What's the maximum you think you could fit in this box?
30.
Maybe 50, 40, thereabouts. Okay.
35, yeah.
All right. Let's count this up then. Okay. So I'm going to give some to you. Count those. Count those. Whoop, watch out. And you can count those. Can you count them up, please? Each one, and then we'll add them up. 9. How many do you have? 7 and 10. So how many is that? 26.
Oh, Jacob's closest.
There you go. Okay.
I said 24.
So
I'm 24.
at the moment, at least, we got 26 chocolates. Okay, 26 chocolates. Right now, here's my picture. Here's what I'm trying to work out. Right, if I have to share this, how many chocolates am I going to get?
None. I'll take one.
Let's think about that, actually. Let's think about what happens if a single person got all of the chocolates, right? Well, there are 26 in total. So, not that hard to work out. They'll get 26 chocolates, right? Do it this way, actually. Okay. One person, 26 chocolates for that person, okay? But let's suppose, hey, Luke, I think that's a bit unfair. I brought the chocolates to class after all, right? So let's split it between you and me. I'll be reasonable, okay, right? So I'll get all the wrappers, he'll get all the chocolates. So if there are not just one person getting them, if there are 2 people, how many will we have each?
13.
We'll have 13, right? Okay, right now, I know it's uneven, but, roughly, I've distributed among 3 people. Now, this is a bit trickier. If I have 3 people, if I were to do it fairly, because at the moment it's not fair, is it, right? If I were to do it fairly, how many chocolates would each person get?
6.5.
Huh.
Yep.
There's 26 to share, right? How many would they get? How would you work it out to make sure
They
it
would
was fair?
each get 6 and there would be 1 left over.
Would they each get 6? Okay, so let me work this out, right? If I've got 3 people and they each have 6 chocolates, right? That's going to be 18 chocolates. And then, how many?
They would each get
There's
8.
more than 1 spare left over,
They would
right?
get-
Okay, so they're actually not going to get 6, are they?
Sorry.
That's okay. That's the whole point of working this out, right? If they were each to get 8, which looks a little more close to what they've actually got, right? That's going to be 24. So there'll be 2 chocolates left over. What should we do with those 2 chocolates?
Chop it into 3 bits.
I should slice them. If I want to be fair,
Slice me into
between 3 people, I should slice them into thirds. That's exactly right. And each person
Gets two.
would get 2 of the thirds. Okay. So we're going to get 8.
So that's 2
And
6
2
and then 1
thirds.
third.
Okay. What if we added one more person in the mix?
6.
Okay. Now hold on a second. I'm going to pause. Right. I want you to think about what is this? What have we just made? What have we just made? Maybe if I put some lines around it, you'll be able to see. Aha! Yeah. This is a table of values, isn't it? I just sort of I fooled you with chocolate, right? Except usually we have X's and Y's. But now, what's this first row about? What did we start with? That's how many people, right? Right? That's how many people. And then this is how many chocolates they get, right? So therefore, these things correspond to, just like these things, they correspond to axes, right? So I've got people on my horizontal axis, right? So I'm working out what happens to the chocolates as I get more and more people. So chocolates is my vertical axis. This is my chocolate axis. If only all the axes were chocolate. Okay. So I want you to think about, well, what happens right? How far could you go?
Could
Right?
go forever.
What
Until
numbers?
26.
Okay, it's interesting. Now, okay, so the first question is, how far can you go? Can you go on forever? Is there some endpoint? If not, or if so, right? Here's my question to you, right? This linear graph, it has an equation like this. Yep. This parabolic graph has an equation like, what did we say? X squared. Good. Thank you, Kai. This exponential graph, it has an equation like we swapped the power and the base, didn't we? 2 to the power of x. Now my question to you is, and this is the last graph under our topic, that's why we're finishing today. Number one, what's this thing gonna look like? And number two, what is this thing?
Waves.
Right? Now I'll give you now the title, right? So I didn't want to give it to you before because you would misunderstand. What we're doing here, this is called, and this is what mathematicians do. It's called modeling, right? Not like catwalk modeling, but we're trying to come up with a mathematical model of something that happens in real life, right? Now, in reality, things might be slightly off. You know, this graph here, it might have like, you know, wiggles and bumps in it, all that kind of thing. But we're trying to understand a mathematical model that gives us some understanding, even if it's not exactly perfect. So, what's it going to look like?
A wave.
What might this end up as? I'll give you a few minutes to draw a picture and then come up with a conjecture.